Hello everyone, I am Rishikesh Kulkarni. Welcome to my channel. In this tutorial, I am going to explain you about stresses and its types. Okay, all of us know the stress is nothing but the internal force generated in the body against externally applied load which is acting on the body. The equation of stress is load upon area. Most of us are in misunderstanding that the stress acts only on the cross-sectional area. It is not always true that stress acts only on cross-sectional area, but it acts on the area, such area which resists the externally applied load. It may be a contact area, it may be a cross-sectional area. You can express the unit of stress either in Newton per mm square or MPa or in GPa. So 1 Newton per mm square is equals to 1 MPa, that is 1 megapascal, and 1 gigapascal, that is 1 GPa, is equals to 10 to the power 3 MPa, that is megapascal, is equals to 10 to the power 6 Newton per meter square is equals to again 10 to the power 3 Newton per mm square. In the next step, I will discuss about the types of stresses. There are 7 types of stresses you have to study. First one, tensile stress, compressive stress. Second one, third one, shear stress. Fourth one, torsional shear stress. Fifth one, bending stress. Sixth, crushing stress. And seventh, bearing pressure. Amongst those, you are familiar with the first three types of stresses. So we will discuss all these stresses one by one. First, tensile stress. Tensile stress is nothing but a stress, that is internal force developed in the body due to the externally applied load, in which the load or the direction of application of load is opposite. Consider a rectangular bar is subjected to a tensile pull of say P kilonewton. Then the stress developed in that rectangular bar, it will be a tensile stress, and this stress will act on its cross-sectional area. As the bar cross-section of the bar is rectangular, that means the cross-sectional area will be its resisting area, and the area will be B into T, that means breadth into thickness or breadth into height. If the same tensile force is acting on the cylindrical bar, the area under stress will be pi by 4 d square. Okay, that means the diameter of that cylinder. Okay, next type of stress is compressive stress. Here, when a component is subjected to a push, that means when a load is acting in same direction, the type of stress developed in the component is compressive stress. Okay, so again this stress is induced in the cross-sectional area of the component. For rectangular bar, again it will be width into height or width into thickness of the component. For cylindrical bar, it will be pi by 4 d square. Next type of stress is direct shear stress. See, when the component is subjected to tangential load, the kind of stress developed is known as shear stress. Now, the shear stress may act on the circumferential area, or it may act on the cross-sectional area of component. So I will discuss about both these cases, when the stress is acting on the circumferential area and when the stress, this shear stress, is acting on the cross-sectional area also. Suppose there is a rectangular plate with having some thickness T. Now if I want to create a hole of certain diameter D, then this plate will be subjected to shear stress. I am indicating this shear stress by tau. The resisting area under this stress will be circumference, that is contact area, that means circumference of the circle, that is pi d, and the thickness of the plate T. Therefore, the equation of the shear stress in this case will become tau is equals to W upon pi dt. Now, suppose in the next case, if we are joining two plates with the help of rivets, and if those plates are subjected to a tensile force, then the shear stress is acting the shear stress on the rivet will act on its cross-sectional area. Suppose small d be the diameter of rivet, then the resisting area for the rivet will be its cross-sectional area, that is pi by 4 d square. Now putting this resisting area into the stress equation, the equation becomes W upon pi by 4 d square and multiplied by small n. N indicates the number of rivets which are required to join these two plates. Okay, the rest of the stresses I will discuss in my next tutorial video. Thank you for watching my video. If you are not subscribed my YouTube channel, then please subscribe my channel for the latest updates of my video. Thank you.